Welcome to episode 1 of Pico-8pril, and today we're going to be getting started with Pico-8. Hey everybody, it's Chris from FamilyGeekery, and today we're starting our first lesson in Pico-8, and we're going to be learning about the interface itself, the program, just getting started with it. So let's go ahead and jump right in, starting off with... If we look here, this is just the program itself, and the program itself, the first thing that I want to show you guys is that the Pico-8, before we even get into, this kind of stuff, the program itself is basically its own little operating system. So it's got its own file system and its own help system. So if we look by just typing in help, then we've got several commands that we can do, and there's some that's even not listed in here. But you can see we can load, run, shut down, reboot, resume, save, a bunch of different things that we can do. So once we start making programs, of course, we want to save them. When we want to load them back up, we want to load them. When we want to test them out, we want to run them, so that kind of stuff. So starting off with just your command line here, if you type in ls, that's kind of a, if you remember the old DOS days of using the command line, that's kind of like the dir. It's your directory. ls, I think, is used in Linux or one of those other operating systems to list out your thing. So you can see I've got a couple different P8 files there, and then a binary file, and we'll get into those later. But you can see I've got some P8 files, which is basically the Pico-8 programs that you're going to be creating. Now, if you wanted to get to these actual files to either save them, give them to somebody, put them in the cloud, or upload them somewhere once you get ready to publish the game or whatever it is that you're making, then they are buried deep inside either Windows or Mac in one of these weird subdirectories that you never look at. So one of the things that I want you to learn first is if you type in folder and hit enter, it's going to pop open the folder that contains these files. So it's an easy way to get to them real quick, and then you can save yourself a desktop shortcut to them if you want to. But anytime you want to, you can just type in folder, and since I'm not capturing my whole desktop, you won't see that pop up. But just test that out, and you'll see that it opens up a folder right on your screen that has these files in them. Of course, if you don't have anything saved yet, then it's going to be empty. But that's your carts directory, and that's what Pico-8 saves everything is in their own carts directory, because that's what these little P8 files are going to be. They're going to be your carts. All right, so we got the ls for listing. Let's see what else is in there. We got load. So if we do a load and then one of those P8 files, I had one called FG for FamilyGeekery, and you don't have to put the .p8. It says it's loaded that fg.p8. 1,125 characters, and that's what this is. So that's that program that I showed you in the first episode 0, and if you haven't watched that, the little introductory episode, you can go back and watch that now. But that's what I showed you there, and these 82 lines of code. And once we get those, we can run them, and that's that little demo that I had running. Now, there is a shortcut also for run, so if we hit escape, that gets us back to the command line, and you can see that it just keeps everything on the screen that was on there, and it just makes the command line go on top of that. But you can hit Control-R on Windows or Command-R on Mac, and that's going to be your shortcut for run. So once you're actually in here and you're coding, you don't have to escape out and type run to test your program. You can be right inside your code editor here and just hit Control-R, and it'll go right to it. So similar to that, we've got save, and that's going to be obviously from the command line. You can type in save. If you don't hit anything, it's going to save the same file that you had already been opened. If this is a new file, then of course it doesn't have a name yet, so you want to actually save and then give it a name. Let's just say FG2, and it's going to save that file which now if I do my ls again, I can see I've got FG and FG2. And now that I've renamed that by saving it, anytime I hit save again without giving it a name, it's going to be that FG2. Now, of course, there's a shortcut for that. So once you're in here typing away and you're getting a bunch of stuff done and you want to make sure you don't lose anything, Control S. And you can see down at the bottom there, it popped up. I'll do it again. Control S, saved FG2.P8. So just like Control R, you can do a Control S, and it's going to be a shortcut for save. So now we can get into the code editor. We can make some code. We can run it. We can test it. We can save it. That's all the really important stuff. Let's see what else is in the help screen here. We've got reboot. That's the next one I want to show you. So if you're working on something and you've saved it and you want to start something new, the easiest way to do it is just do a reboot. Hit enter. It's going to reboot your Pico-8, just like the same little animation that when you start up the program the first time. And now if you look in your code editor, it's completely empty. So hopefully, anytime you reboot, you've obviously saved before you do that, because it's just like turning off your computer and turning it back on. It's cleared all the memory and it's ready for something new. So let's look in the help thing, see what else there is that we want to look at this one. I'll save resume for later. You got load, save, run. Those are the important ones. Shut down. Obviously, he's going to shut this down. It's going to close the program. We don't need that. Install demos lets you install some of the stuff that Pico-8 is included in the program, and several different demos. We're not going to worry about that right now. You can make directories and change directories. So if you have a bunch of programs and you want to kind of categorize them into different games or different projects, then you can make directories in here and change directory just like in DOS. So that's really what I want to show you in this little operating system first. So let's get into the good stuff. Let's go ahead and get into the command editor and start talking about how Pico-8 works and how it runs the programs and how you're going to start designing your programs or games inside this code editor. So let's start off by looking at what I call the game loop, or what they call the game loop. And basically that means is, how is the program running? How is it looping through all the code? How is it taking what you've told it, what you've programmed into it, and making it actually happen? And how that works is through a series of 3 different functions. Now we're going to be talking about functions more in depth later in this series, a couple episodes from now probably. But this is just going to be a brief introduction of functions. And the way you want to think about functions, if you're not a programmer, if you're not a coder, if you haven't heard that term before, or you've heard it but you don't understand it, it's literally exactly what it sounds like. A function is just a function. So think about your air conditioner, right? It has some function. It makes your house colder, or it makes your car colder. So that function, that's all it's doing. It has some task to do. You tell it how to do that task, and then it does it. Now, functions can have inputs and outputs, of course. Like with your air conditioner, you may have a thermostat that you say, hey, if it gets hotter than 72 degrees, turn on the air conditioner. Or if it gets colder than 72 degrees, turn off the air conditioner. So we're going to learn all about functions later, but we need to at least understand what a function is briefly to understand how Pico-8 runs. So Pico-8's base system runs on 3 different functions, and they're going to be called the init function, which means initialize. And the way that we call that is we say function, and you can see the text turned a different color. When I'm just typing, it's kind of that gray color. But as soon as I typed in function, it turned a color. That means that the operating system, or the Pico-8, understands that this is a command. It's one of its reserved commands. So if I say function, and then all of these built-in functions that Pico-8 uses start with the underscore, init, which is again short for initialize, and then we're going to open and close some parentheses. So that's how you define the function. And then everything inside that function until it sees the word end, which again you saw it started gray, and as soon as I finished the word it turned red. Everything right here in the middle is going to be part of this function, so it's going to do this. Now when does it do it? That's what's special about this built-in function. This is an initialized function that happens right when your program runs. So as soon as I hit Control R, it's going to do that. Now, look, it's done nothing because we told it to do nothing. So everything inside that function is going to happen. So we haven't done anything yet, so it's not going to do anything. But that happens just once, as soon as the program runs. Now, the next function you want to understand is the update function. So again, start with an underscore, and then update. And this is going to happen constantly. So it's going to happen 30 frames per second or 30 times per second, as long as whatever you're running this on, whether you're running it on a computer or a Raspberry Pi or a tablet, whatever you're running it on can do everything that you're telling it to do 30 times per second, it's going to do it. Now, if you need it to do faster, then you can change this to update 60, and it'll do it 60 times per second. We're not going to worry about that just yet. If you're doing a game that needs a really high refresh, then you want to do that. But we're just going to worry about update first. So that means everything that's inside this function, which again right now is nothing, is going to happen 30 times per second. And maybe you'll see it happening, maybe you won't see it happening. That all depends on what that code is. So generally, that's just stuff that's kind of bookkeeping, right? It's changing values, it's doing computations, it's moving stuff around in its memory. So all that's happening in the background. And if you want to actually see that do something, then that's when we use this last function here that we're going to learn about, which is draw. So everything inside this draw function is going to happen right after that update happens. So initialize happens at the very beginning of the program. Then it's going to go update draw, update draw, update draw, update draw. And it's going to do that as long as it can, as long as all the code that you're putting in there can be computed 30 times per second, it's going to happen 30 times per second. So right now, again, if I hit run, nothing's happening because there is nothing to happen. And in fact, if you look, if I just go back here to the command line, you can see my cursor is blinking. That's because I can actually do something right now. I can type in run or load or save. But as soon as I hit Control R and run, there's no cursor blinking. That's because the program is actually running right now. I'm not in the operating system right now. The program is actually running. The only problem is I've told the program to do nothing, so it's not doing anything. And if I wanted to stop the program, that's when I hit escape. And as soon as I hit escape, then you can see that cursor blinking again. Now this brings up that last thing we were going to talk about, resume. If I want to resume the program wherever it was without running it from the beginning, then you can do that. And you see, as soon as I hit resume, that cursor went away. The program's running again. Now, the difference is it did not start that init function first. It just continued right from where it was. And I'll demonstrate that just in a minute. So it's actually running again. And if I hit escape, I can stop it from running. So you can run it all you want. You can stop it. You can resume it all you want. You can stop it. But again, I've told it to do nothing so far. So let's get it to do something. The first thing I want to do is, if you notice every time I run it, everything that was on the screen before is still there. Now, normally when you start a new game, it doesn't keep all the other, text that was on the screen. It starts off with a fresh screen, either a splash screen, or it starts off black first, it loads some stuff, and then it starts the game up. So let's get it to do that. So what I'm going to do, and I can do it from the init screen here if I want to, is I'm just going to clear the screen. So CLS means clear the screen. You can see now it turned green, meaning that it's a function. And this is actually, or a command, and this is actually a function. So we call it like a function, just like we called the init function with the parentheses. We're going to call this function with some parentheses. Now I think CLS is one of the ones that will work with or without the parentheses. Nope. In fact, it didn't. I just lied to you. You can do it here, and it doesn't need parentheses, but we'll talk about that in just a second. So let's get these open and close parentheses in there. And now I'm saying, as soon as I start the program, I want to clear the screen and then start the update draw, update draw, update draw over and over again. So let's hit Control R, and boom, it's cleared the screen. I've got no cursor, which means it's actually still running. So it's going to continue to run until I hit escape. Now, if I put some stuff on the screen like this and type run, it's going to clear the screen. It's going to run the program because that clear screen is in the init. Now, if I do that again and do resume, it's running the program, but because that init, that CLS, that clear screen command was in the init, it did not init again. It just started resuming, so the program is running again, but it didn't clear the screen out. So that shows you kind of how that resume works versus run. Again, if I type run again, boom, it clears the screen, starts the program, which again, right now is nothing. So let's go ahead and get that out of there. Let's go back to the command line real quick. I want to show you something that from the command line, you can actually type in commands. Like I said, we did the CLS and it cleared the screen. Now it's not running a program, it's just running that command. So I'm not running my program with like a run. I'm just saying, hey, Pico-8, clear the screen. Or, hey, Pico-8, print hello. And if I tell Pico-8 to print hello, it prints hello. So we're going to get into this print command just in a second. But you can see you can run stuff from here. Now, it's not running the program. So if I go back into the code here, let's put this CLS back in here. And if I want to put something to the screen, then that's a good place to put it, is in the draw. So I'm going to say print hello. And you can see that it understands print as a command. In fact, it's a function. So I put the parentheses in there. I'm going to give it some kind of argument, which we'll learn about. In this case, the argument is just the text hello, and it recognizes that that is text by making it blue. And now, what do you think is going to happen? We're going to go into the init. We're going to clear the screen. It's going to update and do nothing. It's going to print hello, and then it's going to update. It's going to print hello. It's going to update. It's going to print hello. So let's go ahead and run the program. And that's exactly what it's doing. It's typing hello. It's going down to the next line. It's printing hello, going down to the next line. And it's doing this forever and ever. Now, if these were different words each time, then you would see them scrolling up the screen. But right now, just trust me, they're scrolling up the screen. They're just scrolling so fast that we don't see them. And until we hit escape, we're not going to stop this command. So let's go ahead and just hit escape. And now the program stopped. And if I hit run again, you can see it cleared the screen right there and started typing hello. I'll do that again. I'll hit Control R this time. It clears the screen, starts typing hello. And just to show you that resume again, this time it shouldn't clear the screen. It's going to just start resuming that printing command. And there it goes. You could see the resume go right up the screen as it cleared it out with all these hellos, as opposed to clearing the screen first and then typing hello. All right, so hopefully you're getting a good grasp on what the init function is and what the draw function is. We got nothing going on in update yet. So let's go ahead and get something going on in update. So first, before I do that, let's move this CLS command down into the draw. Now, how is this going to differ? We're still telling it to clear the screen. we're still telling it to print hello, and we're telling it to do that over and over again. Well, the big difference is the clear screen is going to happen now every time instead of just right at the beginning when we initialize. So if we do this and we clear the screen, which basically wipes the whole screen with the color black, it starts the cursor back up at the top. Now we haven't talked about cursor position yet. That's going to be in a future episode, but it's going to clear the whole screen with black, put the cursor back at the top, and then do the next thing we told it to do, which is to print hello. So let's hit run. And there it is. It's clearing the screen black, printing hello, clearing the screen black, printing hello. So now instead of printing hello and then doing basically a carriage return or an enter and going down, 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 and pushing all those hellos up the screen, it's just blanking the screen, printing, blanking the screen, printing. So if you have something on your screen that you want to always stay up there, like maybe this is going to say instead of hello, maybe this says score equals, your score at the top of the screen, and you want it always to be at the top of the screen and not moving down the screen as we go, then that's the perfect way to do it, is to clear the screen, print it, clear the screen, print it. So every time that we're looking at this program, it's constantly clearing out the screen and putting the stuff back on, clearing it out, putting everything that we tell it to put back on. So that's going to be kind of a common thing to do if you're putting different text or graphics on the screen, unless you want them just to start putting them on top of each other. That's what you want to do. All right, so let's get into this update function. So let's take this back out again, and we'll go ahead and start this guy off here. And we're going to clear the screen back up here again. And now what we want to do is we want to get into a brief introduction to variables. And a variable is basically just a name that you give to some kind of data. So whether it's a number or some text, that's going to be a variable. So all I'm going to do is I'm just going to call something like num, short for number, and I'm going to say that num is equal to 1. Now, if I'm going to assign something like this at the beginning of my game, a good place to do this would be up here instead. So we're going to go ahead and initialize this variable called num and call it 1. So we're still not updating anything, but now if we want to print that to the screen, we just type in num right here. Now, before, if we put this in parentheses, it recognizes it as text, and if I run it, it's going to say, hey, I'm going to print out num. You told me to print num, I'm going to print num. But we don't want that. We want it to print whatever num is assigned to. So if we take the parentheses out now, then it understands that this must be a variable, and it's going to look in its memory to see, hey, do I have something assigned to this variable? If I do, let's print it. So I hit run, and yep, it sure does. It knows that num equals 1 because we told it that at the beginning of the program, and it's going to start printing that. Now, if I did not assign this, let's just make it the wrong num. If I didn't assign this and I tell it down here to print it, it's going to print nil, which means I've got nothing. So the program is saying, hey, you want me to print num? I've got nothing for num, N-U-M num, so I'm going to print nothing for you. I'm going to print nil. So that just means it's assuming it's a number that has nothing assigned to it. So it's just going to say, hey, I've got nothing. And if you see that, then you know, hey, you must have a typo somewhere. So now that I've got this num set back here equal to 1, and I run it again, we tell it to print num, it prints us a bunch of nums. All right, so now let's go into the update function, and let's make it actually update this number. So I'm going to say num equals, see, I first assigned it to 1, now I want to assign it to something else. Well, I could assign it to 2, and if I do that and run it, it's just going to update it to 2, and it's going to print 2. That's not very exciting. I could have just assigned it as 2 in the first place. I'm going to actually assign it to num plus 1, which means, hey, whatever num is, add 1 to it and reassign it back to num itself. So now, every time this thing updates, it's going to get bigger and bigger, and it's going to print the next number, which is bigger and bigger. So now if I hit run, you can see that 30 times per second, that number is getting bigger, and it's going to continue to print that number over and over and over again until we stop the program. Now, eventually this number will get so big that it will stop, and I think it's around like 32,000 or something like that by the time it stops. But we're going to, we're just going to let it, climb until it gets to something. So that's how the update function works. Now, if I didn't want that number to go down the screen like it's doing, how did I fix that before? Well, I just simply took this CLS out of the init and put it in the draw. And now that number stays right up there at the top because it's assigning the number 1 at the init. It's updating it to num plus 1, which would be 2. It's clearing the screen, printing 2, updating to 3, clearing the screen, printing 3, updating to 4, clearing the screen, printing 4, over and over and over again, 30 times per second. So it's obviously counting up faster than I can talk to you about it. But that's how it's climbing and climbing and climbing. So this is how you would get some number to increment if you wanted to. Probably not a very exciting program at this point, just making a number get bigger and throwing it up on the screen. But this gets you an introduction to the loop itself, how Pico-8 does its game loop. Initialize first, update, draw, update, draw, update, draw. It gives you an introduction to what functions are, the built-in functions, or these functions here, because CLS, like I said, is a function. That's why we put the parentheses in there, and I can give it some information in here. The print is a function that I'm giving some information in here. I'm basically telling it what to print. So just like the function of your air conditioner, what do you want it to do? I want it to be colder. Okay, so that thing that I'm telling it is make it colder. So I'm saying print. If I tell it nothing, then it doesn't do anything. If I tell it to print num, then it knows, hey, I want to print this, whatever's assigned to this variable here. So the CLS, we'll get deeper into this later, but basically it's looking for a color. What should I clear the screen with? And if we look at our colors up here, any one of these 16 colors that you highlight with your mouse, you can see down at the bottom, it says color 3, color 15. So if I look at this color 9 here, and I just simply put the 9 in the middle of here, then you can see it clears the screen with orange, and then it prints the number. It clears the screen with orange and prints the number. So why does it do black? Because if I put nothing in a function, it assumes that it's 0, and the color 0 is black. So if you don't put something in the CLS, it assumes that you want the color 0, which is black, and a lot of times most games start off with that black screen anyways. So that's probably what you're going to be putting in there. But if you do want to have a blue background, then you just find whatever color you're looking for. Maybe this light blue here is 12, and we tell it clear the screen with blue and then print. So we'll get more into print and how to print, where to print. We can print on different places in the screen. We can print with different colors. We'll get more into that in a future episode. But right now, I want you to understand the game loop. I want you to have a brief understanding of functions and just some simple commands. So I think that's enough for this first lesson on Pico-8. Hope you guys enjoyed it. Now, at the end of every episode, I'm going to give you some, I don't want to call it homework, but just give you a little challenge to, hey, take only the things that I've taught you in this first lesson and make something happen. So I'm going to give you a challenge to do Again, if you are very familiar with Pico-8, or if you have a more understanding than just what I've taught in this episode, then you're going to find different ways to do it, maybe even better ways to do the challenge. But I want you to challenge yourself by using just what you've learned here and make this happen. So what I want you to do is I want you to, on the screen here, I want you to end up with the screen being all black, but with the word hello right about here on the screen. Now you're not going to see the cursors, because when the game is running, when you run your game, it should just be fine there. So let's say 10 lines down. So let me clear the screen again. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 lines down, I want you to just have some word, maybe hello, on the screen. So that's your challenge. Now, I'm going to pause the video just for a second. I'm going to write this up, and I'm going to show you an example of how it should look, and I'll be right back. All right, so here it is. So this program is running. You can see the cursor is not blinking, and I've got none of the little carrots on the side of the screen showing that I've typed in commands there. This is just the program running, and I've got hello typed out about 10 lines down from the very top. So this is your challenge for episode 1. If you have problems with this one, don't be upset, because this one, it's called a challenge for a reason. So it's not supposed to be super easy. It's supposed to make you think about how those 3 functions work, how the init function works, how the update function works, how the draw function works, and play around with it. The best way to learn programming is to mess it up a whole bunch. So if you mess it up a whole bunch and then you finally get it, then super. If you mess it up a whole bunch and don't get it, I'm going to show you in the next episode, at the beginning of the next episode, how this works. And this is how we learn. This is how we learn together. So that's your challenge. Feel free to help each other down in the comments if you want. If you don't want any kind of spoilers, don't look in the comments. But there's going to be a couple different ways to do this. Like the saying goes, several different ways to skin a cat. Hopefully you find a way to make this work. So stay tuned for episode 2, which will be Friday. Remember, this happens every Monday and Friday in the month of April, and they'll be continuing on after that, because there's going to be plenty of lessons to learn. And we'll continue this on Friday, and we'll start looking into stuff to make even more fun in this programming language, make more impressive things. So thank you for watching this. Hopefully you learned something. Hopefully you're enjoying it. Let me know down in the comments what you like so far, what you want to see more of, and we will put that on the list of things to learn. But hopefully you like this. Give me a little thumbs up if you did. Give me a subscribe if you want to make sure you don't miss any of these episodes. And stay tuned throughout the rest of the week for more of my normal stuff, which is building computers, video games, controller reviews, just all kinds of weird, anything geeky is going to be on the Family Geekery channel. So thank you for watching, and until next time, peace out and geek out.